Welcome to Cloud on Air, webinars from Google Cloud. My name is Polong Lin, and I'm a developer advocate focused on data science and machine learning. Today, we'll be talking about how to build a demand forecasting solution with BigQuery ML. You can ask questions at any time by submitting them in the box below this screen. We have Googlers standing by to answer any of your questions. So let's get started. In terms of the agenda today in this webinar, we'll be covering the various steps as you walk through the process of building a demand forecasting solution. So from preparing your training data, to creating the time series model with BigQuery ML, to evaluating your model, making predictions and forecasting values for future timestamps and dates. Next, we'll be talking about scheduling and automating model retraining with scheduled queries. Next, we'll talk about dashboarding, so visualizing the forecasts using something like Data Studio. And then finally, I'll dive a little bit deeper into exactly how time series models work with BigQuery ML. All right, so let's think about this canonical example with a store, a grocery store. So imagine that you're trying to make some chocolate brownies and you go to the grocery store and you're looking to buy some cocoa powder, some chocolate powder. As you go to the chocolate powder area, you find that it's not in stock, which is kind of disappointing. And then as you peer over to the other aisle, to the grocery aisle, and you look and you see sacks and sacks of potatoes just kind of there and waiting, but they've already started to turn a little bit green. So they've already started to turn bad. So this is a case where there's a bit of a mismatch between the supply or what's available on the store floor versus the demand. So as a consumer hoping to buy that chocolate powder and not be able to find any in the store. So if they had something like a demand forecasting solution, then maybe they'd be better able to anticipate the needs, the demand of the consumers on a timely basis. So this is sort of a Goldilocks problem, for any kind of retail business. Don't stock too much, but yet don't stock too little with respect to the demand. And this is particularly costly when it comes to either having a surplus of goods on the store floor, especially ones that have some sort of expiry date. And at the same time, too, if you don't have enough of something, then that could be a loss of potential revenue as well. So that's where having as close of a match between the kind of the supply or what's available on the floor and the demand is really your kind of way to optimize revenue for retail businesses. But of course, it's not just for retail businesses. Let's think generally about kind of demand forecasting. So if you think about kind of a supply across time, this is a business's products that's available across time or something like that. And then we actually have a separate curve that kind of shows the actual demand, whether it's from consumers, users, people buying something. So this is the actual demand in this blue dotted line. So as you can see, there's a bit of a mismatch at certain times throughout this graph. And in this situation, we have over allocation where supply exceeds demand. And then in this situation, we have under allocation where demand exceeds supply. In each of these situations, that's where you see some revenue loss or potential revenue loss. And so this sort of framework doesn't apply just to retail businesses. This can certainly apply to other industries as well. Think of transportation, trying to anticipate the number of sales of tickets, or in media, gaming, and telecommunications, where you could have lots of users or players or simply people using your service heavily at certain points of time during the day and maybe less so during other times of the day, and making sure that you have enough, whether it's network bandwidth, servers, any sort of kind of resources that you may need to further allocate during those peak times and maybe dial down a little bit during times where it's less of a peak, just so you can optimize your costs and savings that way through kind of optimizing the supply and demand through ideally forecasting. Now, when it comes to coming up with a demand forecasting solution, there are already many different techniques and products and solutions available to help you build these demand forecasting solutions. But as you encounter, potentially millions of products to forecast, and you need to build out millions of different forecasts and time series models as well, it's not just about the models, it's also about procuring and managing the entire technical infrastructure, and that can get quite overwhelming. It can become complex in terms of the costs, the kinds of people who need to be involved in kind of uh, building out that technical infrastructure. And finally, in terms of your time to production as well, that's also very important because you could have kind of a multitude of products coming together, but then using them all in production can perhaps take too long to be able to capitalize on quickly, so that you can really help your business optimize in terms of its supply chain logistics. So that's where BigQuery ML really comes into play. BigQuery itself is a fully managed serverless data warehouse, and BigQuery ML is this feature of BigQuery which allows you to train and deploy machine learning models just using SQL within BigQuery. So that means you don't have to export any data out of BigQuery in order to train and deploy your machine learning models, which could, of course, take some extra skills or some extra pieces of tools as well. You don't have to worry about that. It's all directly within BigQuery. So you can train and deploy your models in SQL in BigQuery where your data is stored. You don't have to worry about potential PII issues as well, or data governance, because if you have any sort of privacy concerns with the data in your data warehouse, exporting them somewhere else to train your machine learning models can cause some issues as well for privacy and auditing. So keeping track of where your data is in different sources could be troubling. So having that machine learning capability directly within your data warehouse within BigQuery makes things a lot more streamlined. And I've heard of customers who've been able to accelerate going from no machine learning to machine learning models and using them in production at a much faster speed because they were able to use BigQuery ML for their production environments. So let's kind of take a little bit further in terms of looking at kind of what we'll be going through in this webinar. So specifically, I'll go through each of the steps involved in building this demand forecasting solution with BigQuery ML, starting with the sample data set. So this is a retail data set, so it's a little bit easier for everyone to kind of grasp. This is the Iowa liquor sales data. And then we'll be building a time series model using BigQuery ML on this data set. And then we'll go through how do you evaluate the model, make predictions, and then showing you the resulting dashboard as well, and some other best practices like model retraining. Okay, so the very first step is before even considering the model, just making sure that the data is in the right shape and format so that once we do end up training the model, it can be kind of ready to go. So this is kind of the raw transactional data that's available as a BigQuery public data set. If you look up Iowa liquor sales data on BigQuery public data sets, it's available publicly to everyone. And so this is the transactional data. So for each row, you have invoices, you have the dates of the invoice, you have some other information. But importantly for us, because we're trying to forecast demand, we're going to focus on the item description or the item name essentially. So for example, this one here is 99 bananas mini is the first one. And then the number of bottles sold. So that's kind of going to quantify the demand in terms of the invoices over time. And we're going to ignore sale and sale dollars here in this kind of scenario. So here we have the three columns. We have the date, which is when that transaction occurred. We have the item, the product that was sold, and the total amount in terms of the bottles that were sold on that particular date across all the stores to keep things simple. So here we have our select statement. We have the three columns that we're looking for. And here I've simply done a group by summing up the bottles sold across all the stores and across all the different rows and invoices and from the BigQuery Iowa liquor sales public data set. And I'm just simply choosing some date ranges between 2016, January 1st, and 2017, June 1st, so that we can have some historical data. We actually also have some of the actual values from after this date of 2017, June 1st, so that we can kind of compare the predictions from our time series model with the actual demand from June 1st of 2017. So if you were to plot this on some graphs, you could take a look at the time series in terms of the trend, whether there's peaks and so on. So this kind of at least gives you a bit of a visualization as to the demand for this particular product called Black Velvet, which I learned was a Canadian whiskey, or Captain Morgan Spice Rum, which I also learned is apparently a blend of Caribbean rums and some spices. I'm not too familiar with some liquor, so that was a learning bit for me. So our goal here is to create a time series model to forecast the future demand for the next 30 days. All right, as an example. So let's go into BigQuery ML and try to create this time series model. Now, in this exact same interface where we were preparing that training data, we can run our SQL statements to build our model as well. So let's start with the select statement, selecting the training data. Now, I've put the training data in a separate table called training data and under my data set called Iowa liquor. And here you can see I'm just selecting the three columns that will be used as part of the training data. And as you can probably tell as well, there's two really important points I wanted to kind of highlight here. Number one is that in terms of the item name, we have Black Velvet here. You can see on the left-hand side, Black Velvet, but there's also other items as well. So it's not just, doesn't have to be a single item that you're selecting as part of your training data at a time. And another thing that which I'll talk about in a second is that, as you may have noticed, January 4th, January 5th, 6th, 7th, and then suddenly the 11th as the next data point. So there are some missing dates as well that BigQuery ML will be able to handle. Okay, so let's kind of fill out this SQL statement in order to train our time series model. So with BigQuery ML, when you train a model, you're going to be using this create model kind of statement. So create or replace model, and then inside the data set that you want to store your model, we have forecast by product, which is this name that I've simply used to kind of name my model. And then from there, I need to select what kind of model I want to use, and essentially selecting which columns go into what for this particular model. Now, this model type is ARIMA, so it's quote unquote ARIMA. It's ARIMA based, so it's not just ARIMA, which I'll go into later. And then we need to select our three columns. So we have the timestamp column, which is going to be the date. We have the data column, which is our total amount sold, and that's what we're trying to forecast. And then finally, we also have, because we have multiple items, Black Velvet, Captain Morgan, Spiced Rum, so that's why we're also going to have this time series ID column called item name here as well. And so what's going to be happening here is by specifying this time series ID column, this item name column, this query is actually going to be training multiple models where we have one model for each item here. So essentially, if we have, for example, 10 items, it's going to end up training 10 different models as a result, as the output, one for each of your items inside your table, inside of your training data. Another thing to note is because Iowa is a state in the United States of America, we can choose to specify holiday regions that correspond to that particular geography. So in this case, I've chosen holiday region is equal to US. And what that does is it's going to take holiday effects into account in our data for this particular geography of the United States. And if you want, you can choose other regions as well. You could choose global if you have an international market of consumers or users, or you could choose based off of region like NA for North America, or JPAC or EMEA, or the individual country code as well, like US. So holiday region is something to essentially kind of take advantage. But in order to take advantage of holiday region, you just have to make sure you have at least 1 year's worth of daily data, which we do have here. But if you are kind of using your own data, just make sure to have 1 year's worth of daily data. Otherwise, even if you do set holiday region to a particular code, it won't come into effect because it doesn't have that history of in terms of that training data. Now, the other thing, so for each of the items that it's going to be building this model off of, so for Captain Morgan, that liquor, that item, it's going BigQuery ML is actually going to be training up to 42 candidate models. So what's actually happening is it's using AutoArima to try to find the best possible model across these up to 42 candidate models. So it's going to return to you the best model of these 42 candidate models, and it's automatically chosen for you. So suppose you have 1 million unique items. it could potentially, BigQuery ML in a single query could potentially create up to 42 million candidate models behind the scenes. But what you'll end up with is essentially 1 million models for your 1 million items, where it's a one-to-one kind of match there, and you'll be getting essentially the best based off of auto arima there. So it's a very useful function because this allows you a functionality because this allows you to essentially create a single query across lots and lots of potentially millions of products, and then get forecasts for each of the products thereafter. So you don't have to be creating a separate query for each of your individual items. There's going to be some more things that I'll be talking about in terms of building a time series model. What's happening exactly behind the scenes with the time series model in BigQuery ML, like pre-processing or holiday effects. I'll dive a little bit deeper, seasonal and trend decomposition, and trend modeling with ARIMA and AutoArima. So I'll dive a little bit deeper into this at the very end. So if you're interested in learning more, I'll kind of cover that then. Okay, so with that query that I had just shown, this one here that I just shown, we can run this and it will train the model. And as soon as it's done training the model, as I've mentioned, it gets stored in this data set, Iowa liquor. So it becomes this model named forecast by product. And so based off of Iowa liquor.forecast by product, I can now use that model to evaluate and to make my forecasts. Okay, now let's move on to model evaluation. So with the model now trained, we can actually run select star from ml.evaluate in order to check our evaluation metrics. So with 5 items, we actually have 5 models here, as you can see. So for each of these items, the corresponding model is the best model that was selected, as I mentioned earlier, by BigQuery ML based off of AutoArima. So we have, in terms of these columns, we have the PDQ, whether or not these models have drift, the log likelihood, the AIC, the variance, and seasonality. And for seasonal periods, this can be any combination of daily, weekly, monthly, quarterly, yearly, or no seasonality whatsoever. And in these cases, for these particular items, from Black Velvet to Hawkeye Vodka, only weekly seasonality was detected by BigQuery ML. In terms of using the BigQuery console, and I can show this later on in the demo, you can actually click on the evaluation tab. And when you click on the evaluation tab, without even needing to write any code for select star from ml.evaluate, you can actually see all the results for each of the time series models produced for each of your items. You can see it's a little bit small, but there's one for Black Velvet all the way down to Hawkeye Vodka. Okay, so that is model evaluation. Next, let's move on to predicting the forecasted values with BigQuery ML. And to make your predictions with BigQuery ML, you can use ML.FORECAST. And I'll talk about the SQL in just a second. Let's first focus on what it actually produces first, and then we'll go into the code afterwards. So essentially, when you run ML.FORECAST, it's going to give you your item name, so what it's forecasting, the timestamp in the future that it's going to be forecasting for. Then we have the forecast value. So this is going to be in the same units as the training data. This is going to be the forecasted number of bottles sold. And then we have the standard error, the confidence level, which I set to 0.90. And then we also have the prediction interval, the lower bound and the upper bound, which essentially is the range in which the prediction is expected to occur between the lower and the upper bound. So if you were to plot this and adding in the historical data back into the forecast as well as the actual values as well, you can plot this on a graph and compare between the forecasted values and the actual values if you have them. And of course, you can see for the most part here for Black Velvet and Captain Morgan Spiced Rum, the actual values fell within the 90% kind of blue confidence interval there. Now, in terms of the code itself, to use the model to make your forecasts in SQL, you can use this command, select star from ml.forecast, followed by model and then the model name, and then pass in 2 important values. The horizon, which is the number of time points or timestamps to predict in the future, up to a maximum of 1,000 data points. And so in this case, given daily data and that we had said earlier we want to forecast a month ahead, so we select maybe a value of 30 for 1 month of forecast values. And the confidence level is something I set to 0.9. And this is, like I mentioned earlier, this is the percentage of the future values that fall within that are expected to fall within that prediction interval. Now, just to make the confidence level a little bit easier to understand, here we have three forecasts plotted at three different confidence intervals for exactly the same model. The only thing I changed was the value for the confidence interval. So at the very top here, we have the 80% confidence interval. And as you can see, the buffers or the intervals are tighter and closer to the forecasted values, the orange kind of line. And at the very bottom of these three graphs, we have the 99% or the 0.99 confidence interval. And you can see the ranges are quite a bit more looser. So you can be really confident that whatever the actual value of the demand will be is going to be likely to fall within this confidence interval. Now, note that regardless of the confidence interval, the forecasted values are they're going to remain the same. This orange line essentially remains the same, even though the ranges are going to be different, and that's essentially based off of your confidence interval, that value that you set when you run select star from ML.FORECAST. So how do you choose the confidence interval? Well, that's entirely up to you and your use case. So you have to decide that. Do you want to be very, very certain that the actual demand will fall within your predicted ranges? Then maybe opt for a bit of a higher confidence interval like 0.99. Or do you really want to have slightly narrower predicted ranges to help you better optimize maybe your products and resources, knowing that sometimes it may go potentially outside of the prediction intervals? Then maybe opt for something like 0.80, or at least in this case, it could be lower in your kind of use case as well. So I'll leave that up to you to decide, for you to decide. And it's often helpful to have these plots of different confidence levels to be able to understand what might be most suitable for your use case. Okay, so that is model predictions with forecasted values. The next section that I want to cover is around what do you do when you have your first model created and you're ready to use it. You're using the forecasted values with the prediction intervals, but then new data comes in. And then so now you want to retrain your model. So you're trying to figure out a way to help automate this process. So in this next section, I kind of want to cover this common kind of problem or scenario, what to do when you have fresh data coming in on a weekly basis, on a daily basis, on an hourly basis, and how do you retrain your model so that you can schedule it, you can automatically update your model, so your forecasts are always going to be based off of the most recent, or at least inclusive of the most recent data available to you. Okay, so in order to do this, there's something that's very, very convenient to do directly within BigQuery. So you don't have to use other services if you don't want to. And so essentially what you can do is for any of your SQL queries, which can include your create model, your ML.evaluate, your ML.forecast queries, any of your SQL queries, you can choose to schedule them to run on specific dates, specific times, how frequently, on which dates, on which weekdays as well, and so on, when to start them and when to end them. And so that's all available to you directly within BigQuery using what's called scheduled queries. And what's also quite nice is that you can also send notifications, whether you want it by email every time that this particular query has finished running, or if you have some other service that you want to trigger downstream automatically, then you can also send a notification to a pub subtopic. And as long as something is listening to that pub subtopic, they can wait for these notifications to occur that the model has, let's say, finished retraining. So then it can, maybe send some notification downstream to optimize your supply and optimize your supply chain logistics downstream as well. So either way, whether you'd like email notifications or to trigger something automatically, you have those options available with scheduled queries. And this is kind of the menu of kind of changing the options for the scheduled query. But to actually access this kind of menu is you can simply go to schedule and then create new scheduled query there. And then you can essentially schedule any of your SQL queries, like your create model query. When you actually end up creating your first scheduled query, it will show up under this section called scheduled queries on the left-hand side. And as you click on that, you'll see, for example, this one that I've created, retrain demand forecasting model. I've set it to be a scheduled query to happen every Sunday and every Wednesday at 5 p.m. UTC. You can see the next one is scheduled, well, this is from before, but this is December 2nd of 2020. Okay, so now that we have this kind of system in place, this kind of solution in place where not only have we trained our demand forecasting model, we now know how to automate it, you might want to think of visualizing this as a next step. So visualizing your forecasts and seeing how they compare to the actual demand as well, and putting it all together in a dashboard using something like Data Studio. Now, I'm aware there's lots of different kinds of different visualization tools out there. So, at this point, feel free to use whichever visualization tool you're most familiar with or one that you want to use. But in terms of the data itself, I'd like to kind of provide some recommendations as to how to best prepare it so it's easy to visualize. So, given historical data of demand and your forecasted values from BigQuery ML, it's really helpful sometimes to combine them together so it's a little bit easier to kind of visualize in a dashboard. At least you don't have to query multiple things and do a lot of heavy lifting when you're trying to visualize something from a view or from a table. And that's kind of where you could potentially combine them together in a single view. And to do so, what you can do for your historical data, so here in the top we have the timestamp, item name, history value. We can also create these 3 extra empty columns for forecast value, as well as the prediction interval for the lower bound and for the upper bound, so that you can combine that using union all in SQL with the forecasted values. So here under the second chart here, we have the timestamp, the item name, and then for history value, that's going to be null, of course. But then we can add in here the actual forecasted values, the prediction intervals, the lower bound, and the upper bound based off of ML.FORECAST. So by combining them together, you can use something like this in SQL. So here you can see we have create or replace view, IOL looker dot, and here I've created this name output data studio as, and then in this blue section here, this is my historical data. You can see I've created these null values for my for these columns that are going to be used for the forecasts. Union all followed by my forecasted data as I've mentioned, and also keeping in this extra column for history value as null. And so this just kind of helps you create a single view for both your historical and as well as your forecasted values into a single view, so it's a little bit easier to help you visualize. So at this point, I'd like to switch over to show you an interactive visualization, a very simple one, but just to kind of demonstrate what you could potentially do with something like Data Studio. Okay, so here I am in my Data Studio dashboard that I've created, and it's interactive. So currently it's looking at all the products that I have forecasted and the historical data as well. But on the right-hand side, I can select which product I want to take a look at in terms of the historical values and the forecasts. So for example, Black Velvet, you can see it kind of grew in terms of demand during May, but the forecasted values for June kind of are within these ranges of orange and pink, and then the forecasted values themselves are this kind of teal or light blue color, this line. And I can choose kind of between each of these items and take a look at, these are just the 2 months history of demand followed by that 1 month of forecasted values. And you can see generally, like visually speaking, they all seem to look pretty good in terms of drawing out, or at least mapping out what those forecasted values ought to look like for each of these products. Because again, when you're training these models in BigQuery ML, it's choosing up to those 42 candidate models and choosing the best possible model to be able to create your forecast and to create your time series models. So that's quite nice there. Now I want to take a quick moment just to kind of switch over to the BigQuery console and just to kind of show you where that model that I trained was stored in my data set in my project. So here I have my project that I'm in. Under my project, I have my dataset Iowa Liquor, and within this dataset, I also have a couple things here. So first, I have my model, which I've clicked on, as you can see in this kind of main area. You can see the details of the model when I trained it and so on. You can take a look at the training, some information for training. And importantly, this is the evaluation metrics. So you can see here the time series ID, the PDQ values, and the other metrics here available. So you can quickly see kind of what models were, just to remind yourself what models were created for each of the items. I also have, of course, my training data here as well. So this is just the data that I trained on. And then also have a separate view, as I had shown earlier. This is the view showing all the history and also the forecasted values and prediction intervals, which I would then use in this dashboard, just to make things a little bit easier and cleaner as I visualize the data. Now, at this time, I want to shed some light on what's happening behind the scenes when you're training a model in BigQuery ML. So when you train a time series model with BigQuery ML, there's actually multiple components used in the time series model creation pipeline. So ARIMA is one of the core algorithms, but there are also other components that are used. So kind of describe each of these in roughly the order that they're run. So the first step is pre-processing, and this includes automatic cleaning adjustments to your input training data or your input time series data. And this can include dealing with missing values through imputation. They can deal with timestamps that you've have in terms of duplicated timestamps. It'll take the averages. And then there's also anomalies or abrupt changes in your input time series that it will kind of detect and account for as well before training the model. And so what that means is a lot of this cleaning is actually going to be happening before any of the modeling takes place with time series in BigQuery ML. After the pre-processing is done, next we have holiday effects. So by default, holiday effects, as I mentioned, is going to be dependent on the amount of data that you feed into the model, which requires you to have at least 1 year's worth of daily data. So by default, holiday effects modeling is disabled. So you have to specify your holiday region to be, for example, US. And as soon as you do so, as long as you have that yearly's worth of daily data, then holiday effects will come into play. Now, with holiday effects enabled, what that means is any spikes and dip anomalies that appear during these holidays for that particular region will no longer be treated as anomalies. So that really to kind of take into those peaks or anomalies into consideration when modeling your time series data. And you can find the full list of holiday regions if you go through the create model documentation for BigQuery ML. The next step is extracting the seasonality and the trend from your input time series data. So this is done using two algorithms. So this is the STL, or the seasonal and trend decomposition using lowa algorithm, as well as the ETS algorithm, which is the double exponential smoothing algorithm. And then finally is the actual trend modeling taking place with ARIMA and AutoARIMA. Now, it starts with, of course, creating an ARIMA model, and through AutoARIMA, it tries to find the best possible hyperparameters, so creating up to 42 candidate models through ARIMA and AutoARIMA. And by training and evaluating all these different kinds of candidate models in parallel, which include tuning for P, Q, and drift, then it will return to you the best model with the lowest AIC score, or this is the Akaike information criterion. So that is how BigQuery ML creates your time series models for each of the items that you pass in. Now, in this scenario that we talked about with the Iowa Liquor sales data, we had an input training data with lots of different items. You can also, of course, create it with just a single item at a time. In that case, you don't really need the item name or the item ID column when you create the model, and that's completely fine. When you do so, you'll see all the iterations that AutoARIMA goes through to create the best possible model. So if you want to look at how BigQuery ML came up with the best model for a particular product, I recommend using create model on that particular product and only that product, so you can see all the different iterations and see the PDQ values that I tried to iterate through and how I determined based off of the lowest EIC score. So that is kind of how you can kind of best use BigQuery ML for individual as well as for lots and lots of products, with potentially millions of products. Okay, so now hopefully you should know how to build and deploy a demand forecasting solution with BigQuery ML. Just to recap, we covered how do you prepare your training data based off of raw transactional data from this Iowa liquor sales data. We covered how to train your BigQuery ML model for time series modeling across lots of products. You learn how to evaluate your model and the different metrics that are involved. You learn how to create your forecasts and also the confidence intervals as well. You went through how do you prepare the data for visualization through something like Data Studio, and also some best practices, including how do you schedule and automatically retrain your models on a recurring basis with notifications. So with that, thank you so much for tuning in today. Please visit cloudonair.withgoogle.com for more hands-on learning, training, and demos from Google Cloud experts. See you next time.